Hello. So today we're going to be talking about recovering data from iOS devices through using input and output along with the live syslog. So I am Nick Dubois. I work for Hexordia. We are a forensics organization. I've done plenty of other research in the past, and I've been spending a lot of time on iOS. So just to get right into where digital forensics looks in 2023, we sort of just have a very rough outline where if we have an older phone, it doesn't matter if we know a passcode or not, we could get into the phone no matter what. But if we do have a newer phone, typically we will need to actually get the password in order to either jailbreak or use some other service to get into the device. And essentially, if we do want that full file system, we are exploiting the device. Even all of the premium tools, which sometimes we don't know exactly what they're doing in the background, they're still exploiting the device in order to get that full file system. Now, we also sometimes might opt to get a logical acquisition, and that's just going to be if we can't get that full file system for some reason and we still want some data, we might opt to get something like an iTunes backup or a sysdiagnose log, and once those are downloaded to a computer, we can parse them later. So with an iPhone X or below, like I said, you can either exploit the device with a passcode or exploit without a passcode, it does not matter. But with the newer devices, you will either need a passcode or you will need a private exploit, which can somehow exploit the device without a passcode, but none of these are public. And essentially, we will need that passcode if we do want a full file system. Now, in terms of logical, either we have a passcode and we can trust to a PC, because trust is needed to back up the device through iTunes, and trust is typically needed to get a sysdiagnose log. So without that passcode or without trust to the device, we won't actually be able to get this logical acquisition either. So before we get into what we're taking a look at, we're just going to roughly go over some of the device states. First off, there is BFU mode, and this is before first unlock. And essentially, once you fully restart an iPhone, until you unlock for the first time, it's going to be in this mode, and it's going to be a little locked down more than normal, and this makes it a lot harder to get our acquisitions. There is after first unlock, so this is just after that phone's restarted and you unlock it at least one time and type your passcode in, and then it removes a lot of these restrictions we saw in BFU. Next we have recovery mode, and this is the mode which is usually used just to restore errors on a device. When you plug this in, you can just factory reset and update the device, but we can't do a lot in terms of forensics through this mode. Then we have DFU mode, which is device firmware upgrade, and this is a very low-level mode which is used to flash devices, and it looks like the device is actually powered off with a black screen. However, if you do plug it into a computer with compatible drivers, you will see that it is not actually turned off. And this is a very simple mode where all you can really do is send images to the device. You can't really talk to it like we can in most of the other modes. And we have diagnostics mode. And many people do not know about diagnostics mode, but essentially you get here by fully shutting your device off, holding both the volume up and volume down, and then plugging it in, and then letting go of those buttons once you see the Apple logo. Now, there's not much that can be done in here. This is really for the developers at Apple. If somebody's having an issue with the device, they can take it and put it in this mode, and then they can query data from your device. Now, we won't be able to query data because we do not have the same tools as them. So once you click Start Diagnostics, if you're just a user and your device isn't actually prepared to go into diagnostics on their end, it will just give you an error and you'll have to shut the phone off. Now, one thing that's immediately useful in this mode, however, is if we click the little informational icon in the bottom right, we can get a few identifiers such as the serial number, the MEID, and the IMEI. Then there is the trusted or paired state, and this is going to be after you restart your device, you unlock it, and when you do plug in to a Lightning or USB for the first time, we'll get this little pop-up that says, do you want to trust the computer? And we will need to hit on trust to get most of our logical acquisition data. And then there is USB restricted mode, which is a little bit of a newer feature, and essentially it will just make it so you cannot send any data over USB unless you've unlocked your device within some period of time. It used to be a lot longer, being in days, and recently with newer updates, it's just a matter of hours until your device goes into this mode, and you'll either have to unlock it or put it in a different state. But unless you're able to unlock the device, it will fully shut out all of the USB traffic, and then without a passcode, we will not be able to get either full file system or logical data. Now, one thing we can do is actually plug a dongle in, and the dongle will prevent USB restricted mode from activating. So essentially, we would find a device at a scene, say it was unlocked 10 minutes ago, we don't know the passcode, but it's not yet in USB restricted mode. If we get a good dongle, and you'll have to test for yourself, it kind of varies, some of them work, some of them don't, but if you put a dongle in, and even if it's not connected to anything, it will actually prolong USB RM for activating, even though we have not unlocked the device. So we can hold it in this state until we are able to get an exploit or something over USB, and we can just keep it in storage and make sure it's powered on, it doesn't shut off. And in this state, it gives us a lot of hope for finding something eventually. So now we're going to go into some of the data sources that we looked at. So we don't expect you to actually read all of this. There's a lot of data sources on iOS, but essentially there's some of the really raw data, like the raw hard drive, and we won't be able to read that because iOS really encrypts everything, and you'll have to read the data through the device. So we will have to look at, the touch UI or the user file system or the full file system if we're able to get it. But then there's also things like RAM, which we don't typically look at, and there's some data like live data going over USB, which we don't typically look at because it's just so volatile. But it's important to note that if you do take a look at the right-hand side, all of this data is volatile, at least somewhat. So we do want to get everything as fast as we can. Even if we can't get the full file system, the files are getting deleted automatically from the full file system, and we're losing data very rapidly. So as soon as we get a device, even if we can't get the FFS, we do want to at least attempt to get some form of logical data. So the first way that we took a look at getting this data is through sysdiagnose logs. So sysdiagnose logs are a collection of diagnostic logs which are output to a tar archive. And just for an example, like it would run the ps command and list all the processes running, and it would output it to this file. And this is really meant for developers to figure out issues, but we can obviously take advantage of this through looking at timestamps and all of these logs and piece together a timeline of what happened with the device. There is actually a few different ways to capture a sysdiagnose log. So any iPhone or iPad, you could hit the volume up, volume down, and power button all at the same time, and you would hold that for about 1.5 seconds, and then your device would vibrate, and then we will see later on that it has collected a log if it has vibrated. Now, iPads will not vibrate, so you will really just have to wait about 10 minutes and then see if the log has populated or not. Alternatively, you can actually get a log by going to the settings menu. So you go to accessibility touch, you'd go to the little assistive touch, and you'd configure it to actually take a sysdiagnose log. And then wherever you're from, you could just hit that little button and it would get a log. Now, this is really important only because sometimes we get devices where some of the buttons don't work. So say your power button doesn't work or one of your volume buttons doesn't work. This gives us something. If we do have the passcode and we can unlock the device, this gives us somewhere to go. And this log is also recoverable from other device modes. So even if the phone is fully locked, you can still click those buttons and it will take a log. You will not be able to export the log just yet. However, at least if you do capture those logs, you are saving the data permanently on the device. So you don't have to worry about that data getting deleted. Now, if we actually jailbreak a device and SSH in, you could actually just run the sysdiagnose command, and that would also get a log. And we can see when we run this command that it actually has all of these options, and we can set different options however we wish. But something interesting in here, when we run it, we see two things. First off is sysdiagnose needs to be run as root. So if we are somehow able to take advantage of this process through the touch UI or something, it's important to note that it is running as a root. And secondly is there is a little hotkey where it says Control Option Command Shift period, and essentially that's because this is literally just a Mac OS application ported over, and there is not a huge difference between a lot of the Mac OS and iOS applications in the back end. So I decided to try it out. And with that same dongle, I plugged the USB in, and with the keyboard, I hit that little key cord, and the phone actually vibrated, and it actually took the log. So now to get into the contents of the log, the task summary.csv file actually gives us a very quick output of all of the commands that were run. It does leave a few of the beginning commands out. So what I did instead was just made a little one-liner in bash, and it would just pipe all of the commands that were run out to a text file. And then after I did that, we could see which commands were actually run. And when you take a sysdiagnose log, it runs, I think it's roughly about 60 commands, and it dumps all of this data. We have PS, we have which processor running, memory dump, a lot of different things, a lot of networking and USB, and it just pipes all of this out to various files and then shoves it all into that one archive and then archives it. So to actually get these logs from the device to our computer, we have a few different methods. First off, if we go to Settings and then Analytics and Improvements, we can head to the Analytics Data section. And here we will see all of our logs. Now, at the bottom, we have a sysdiagnose log, but if you see, there's actually tons of logs in there. I think this phone, I just went in there, and without even making these logs manually, I think there were a few hundred logs on my phone just from applications crashing. And if we do use all of those logs, we can get a really good pattern of life of what the user was doing on that device. So alternatively, we do have a tool which we have up on our website called the sysdiagnose toolkit, and this uses one of the tools from libiMobile device, and essentially all you would do here is you can pair your device, and then you can click on whether you want to keep the logs on the device or simply export them and then delete them from the device, and then you could just click on export logs. And additionally, iTunes actually does this all by itself. So if you open iTunes and you've ever plugged your phone in, you might have noticed that little thing at the top that says syncing with your device, and it will like copy your music over, but it's also copying all of the logs over. So it will actually copy the logs and then delete them from the device. So if you do take a look at your computer, and even if you're not looking at the phone directly, if you just have a computer up for examination, if you go to the path where this is stored within app data, it will oftentimes have logs in there. I think I plugged it in from my laptop, and I just took a look at this folder, and I had logs from phones that were like 9 years old. Some of the phones weren't even mine. I don't know how they got there, but there's just a lot of logs in here. And obviously, going through these, you can get a very good timeline of each of these devices. So next is syslog. So whereas sysdiagnose log is something that you capture and save to a device, syslog is actually a real-time log, which requires trust again. And essentially, you would plug this into your computer, and then from the computer, you would start the log, and you would monitor in real time. Now, for capturing syslogs, there is a tool in the lib iMobile device toolkit called iDevice syslog, and you would just plug your device in and then run this tool, and it would output all of this straight to the screen. However, there's a big issue in this, being that you do get hundreds to thousands of lines per second, and it is very hard to manage. Now, we have a tool which just came out a couple weeks ago called the iO+S toolkit. And this, again, in the back end, uses the iDevice syslog tool from lib iMobile device, but it will also actually parse the log in real time. So we see here on the right, we have just a list of identifiers. They're all set to null, and then we plug a device in, and they will populate. And then if we just hit on start, we'll notice that on the left side, we will have all of our log populating. So here I'm just pairing the device, and then I click on start, and we can see this is essentially how fast the log goes. Nobody wants to parse this by hand, and a lot of the times, some of the artifacts we're looking for, you'll actually have to run the log for like several minutes. So at that point, you have tens of millions of lines, and we're obviously not going to parse that by hand. So once you let this run for a little bit, we have set it up so you could go to the next tab, the syslog analysis tab, and it will parse some of this information out. So we can see here we just have some generic info like the available storage, but then if we go up a little bit, we have part of our iCloud email. And then we actually have the SSID and BSSID of every network that we've ever connected to. Now, there is additional information that can sometimes be found. If we do have auto join configured on a network, it will also actually give us the last connected time of this network, along with a physical geolocation, latitude, longitude of the network, and a lot of really nice, useful information. And then at the end, we could export these logs to a folder. And something else we decided to look at was USB endpoints. So what can we scrape by looking at raw USB data from a device? So looking at an iPhone X running iOS 16, we wanted to know how many endpoints are actually running on this device. So that's a lot of endpoints. We have 19 endpoints in our device when we're booted into normal mode. And a lot of these are some set aside just for charging, some are just for audio, some are just for video. But 19 endpoints is a lot of endpoints, and some of them are very undocumented. For example, FireWire is still running on an iPhone, which is pretty strange. And we're actually able to send data over all of these endpoints and query for information. Now, in recovery mode, we have a few endpoints, not as many, 3, but it's still more than 1, which is concern to look into more. And DFU mode, we really only have an endpoint for input and output and charging. Now, diagnostics mode, once again, actually has the same endpoints as normal mode. So it really boots into a pseudo-normal mode. It's using all of the same backend. However, the endpoints do act a little differently. In this mode, no matter what, if you have passcode set or not or anything, it will always consider that your device is locked. So when programs interact with our device, they go through USB MUX-D and a layer of SSL encryption. Now, essentially, how this works is we would plug our device in, and if we hit on trust, it will establish a secure connection to our device, and that allows us to query more information. Now, there's a little bit of an issue with this, however, and that is considering some Windows applications. Some programs will first try to establish that secure connection, and if it cannot get that connection, it will still attempt to get the data, but then the device will just say, hey, you're not trusted, and then it will have to exit. Other applications, however, it will exit on the computer side before it even attempts to gather that data. And it turns out a lot of that time, if we actually just make the query ourselves, not going through any of these programs, we are actually able to still get the data without trust on the device. So when we're working with USB endpoints, we really have two things we can do, and it's just we can send data or we can receive it. So we can capture the data and then view it ourselves, or we can send custom requests to the device. As for capturing USB data, we opted to use USB PCAP, and this is a very simple tool. You would just run the command, and then you'd plug your device in, see what port it's running on your PC, and then you start capturing, do whatever you want on the device, and see what comes back. So to actually see which data is coming from our iOS device, we can search for the plist, because almost all of the data going to and from this device is going to be wrapped within a plist file. And when you do interact with the device over USB, you are actually sending entire small files to the device and then receiving small files back. Now for, again, the USB traffic, sometimes we're able to see tokens and certificates when we are locked and unlocked. So this means that we're still getting some tokens and data even if our device is locked and we are fully untrusted. So we're still able to get data, which is pretty important because we could have a fully shut down, completely locked device that we can't get any full file system or really logical acquisition from, and we're still able to receive data. Now, USB RM kind of ruins everything. Essentially, it will block out all USB data until you do unlock that device. Now, even if you've noticed you have a newer iPhone, you've plugged it into a laptop, and maybe it's not charging until you unlock the device, it even actually blocks out the charging endpoint until you do unlock that device. Now, one way to get around this is just to take a look at the pairing records, and essentially this is just the code for the trust that's established after you pair your iOS device to a PC. And what you can do is locate this, which is found in the program data directory for Windows or the lockdown directory for macOS. And you could take this pairing record, which is just going to be titled the GUID for your device, and you could actually use this to manually establish a trust with your device from any computer. And better yet, USB RM can be sort of bypassed through diagnostics mode. So diagnostics mode does not really know what USB restricted mode is. And this is useful because, again, let's say we're in the worst state possible, phone's fully, completely locked down, not even able to get USB data from it. If we do plug it in this state, we will at least be able to send and receive data to and from the device. And again, like I said, it considers that your device is going to be in an always locked state. However, this is still going to be more data than we can get literally anywhere else. And it turns out in this state, we're still actually able to get some very, very useful data. So while I was in this state, I just booted up iTunes and then started plugging and unplugging the device several times while monitoring it. And it turns out that we were able to dump some data from the photos.sqlite file directly from the device. So it tried to attempt to sync to our PC, even though we're not trusted or paired, and it actually gave us some very good information, such as the names of photos, the full path to them on the device, where they were taken with a latitude, longitude, general area and like city, and then it also gave us a timestamp of when some photos were taken. Now, again, the iO+S toolkit comes into play, and we are able to parse USB traffic. This is not released yet. However, it will be released in the coming months. So next thing we looked at was actually recovery mode. So libiMobileDevice has a tool called iRecovery, and essentially you can use this to send and receive data in recovery mode. So it's very locked down now. There is always some form of exploit which is eventually going to come out leveraging recovery mode. However, right now the only thing that's public is kind of just the getEnv and setEnv variables. So you can set some very simple environmental variables, and then you can also get environmental variables and dump some very rudimentary information. So we can see build version, a few other very basic things. But the really important ones are we can see part of the iCloud account. It's only going to be the first two letters of the username and the first two letters of the domain name, but it's at least something. And also, we're able to see if the device was reset recently, and we can see a timestamp if it was reset very recently. So we attempted to actually fuzz recovery mode, and we tried 3 different things. The first thing was actually trying to fuzz the commands. Then we tried to fuzz parameters for a getEnv and then for setEnv. And we didn't find too much. We found all of those getEnv variables, but we were also able to crash the device several times using raw commands, which crashes lead to exploits. And so just a full case study of what can we get from a locked device. Now, if we are in a paired device, we can get sysdiagnose logs, we can monitor the live logs, we can get iTunes backup, all of the nice logical stuff. If we're lucky, we can get a full file system. But if we're paired, a lot of the times we can actually just look at the UI, and that covers a lot of our more sensitive information sometimes. And alternatively, we could put it in these other modes such as recovery, DFU, and diagnostics, and to get that data. And then we also have API data. So if we do actually make calls out to the Apple code base online, a lot of the times with nothing even more than the GUID of the device, we actually are able to get a lot of information. Now, let's say we have an unpaired device. We will be missing a lot of that logical data, such as the backups. However, we can still talk to Siri. We can get the recovery and DFU mode data. We can still get diagnostics data. And it is still possible to get sysdiagnose logs. So, considering a case study, we have an iPhone X that is locked down in essentially the worst state possible. What can we actually get? So in diagnostics mode, we can get some of our basic info, such as the serial number, IMEI, MEID, and while this might not be directly useful to an investigation, we could actually use all of this data to query API endpoints and contact Apple servers and get a lot more information about these devices. We'll also get the iOS version and then some of the baseband info, and this can just be used to determine if our device is exploitable. Next, we have APIs. In this case, we were with nothing more than the GUID, able to get the full email address of our iCloud account, the first and last name of our user, and additional generic iTunes information. Now, from a recovery mode, it's just some more basic info, the device model, the IMEI part of the iCloud email address, and we were able to determine that the iCloud was locked, and obviously that means that the device is in lost mode and it will fully factory reset or lock itself out at the very least if it is able to connect to the internet. So now we know this device cannot touch the internet and it's got to stay Faradayed. So next we are taking a look at the sysdiagnose log. There is a lot of rudimentary device information such as the device info, so it would be like Nick's iPhone. We could get the languages and keyboards of the user. We could see when the device was fully powered on. We could see when applications were run and when screenshots were taken. And then we can see every single time that device contacted USB, the full date time of when that trust occurred. We could see the battery percentage when that occurred, the device orientation, charging status, brightness, and motion. So motion would be if you're in a car, if you're standing, etc. And related to applications, we could see all of the applications that were installed. We could see the versions, the permissions. We could see which ones were currently running, and then along with all of the backend processes. And we could see the previous application runtimes. For Wi-Fi and Bluetooth, we were able to get the hardware MAC, which is very important because most newer iOS devices will automatically use a rotating MAC address. So you could get historical data in terms of when this MAC rotated and the seed for it. We could see all of the connected SSIDs, and as I said before, we could get some very good networking information such as lat long and timestamps. And then again with the cloud, we could get the full name, the username, email, some API keys which could be used to get even better data. And in the sysdiagnose folder is a folder called logs, and most of the logs, the nice logs, such as transparency, consent, and control database, which actually manages the permissions of every application, can be found in this folder. So we have some of the things like that. We have the power log, application usage logs, the mobile installation logs, our email address from our calendar, device profiles, when we've had lockdown statuses, and then when we've updated and restored the device. And a lot of these logs, even when we get a full file system, this is what we're looking for, is going straight for a lot of these logs. And we're able to get all of this without even a full file system. So alternatively, there is a log archive, and the log archive will hold essentially just dumps of logs going back days, even when the device has been restarted. And if we do parse all of this data, we can get a lot of very good information. One thing that we can get is actually the phone numbers or emails, if no phone number was set up, about the airdrop. So when you send an airdrop, it actually uses your phone number as a hash, and it sends it to the other device. And if you do take a sysdiagnose log, you can actually recover the phone number. We could also get AirTag logs and locations from that. Device orientation, installed apps, Safari history sometimes, and then contact information. So the key takeaways is just to find more endpoints. When I started this off looking at iOS, I was really looking at it as a lot of people do, just looking at like the really three basic endpoints through DFU mode, recovery mode, and trying to find really crazy binary exploits through here. But it turns out that I was actually able to find a lot more data by looking at it almost like a bug bounty, and just start off by finding as many endpoints as I could possibly find, and then trying all the simple stuff against those. We also used a full file system to find a lot of these endpoints. So, for example, we found one of the USB endpoints and then you could take a full file system and search for that one, and turns out that all of the endpoints are in the same file, and you can just get a list of all of them right there, nicely packaged for us. And lastly is that diagnostics mode actually exists. This mode is very not locked down, and there's a lot of information that we can get from here, and it is worth researching. So for future work, we would like to fuzz both DFU mode and recovery mode a bit more, and we would like to take a look at the diagnostics mode API, because Apple is contacting this endpoint somehow, which means other people can probably contact this endpoint somehow and get even more data from here. Now, all in all, we were able to find that essentially we can get a lot of information from here that we never thought we could get. When we have a fully locked down the device, we're in USB restricted mode, like the worst state we could possibly imagine. We'd never be able to get data from these devices. It turns out that we could actually get quite a bit of data from these devices, and it's always worth researching a bit more. And we have time for questions. Okay.
Are you surprised how much information you can get out of phones?
Mm-hmm.
And you're standing, it's like, oh, we got all these things, and it's like, you go like, all of that? From the lockdown one.
Yep.
So, okay, all right. That was more than I thought. So people who want to dig into this, where's the best place for them to start digging, you think? Where do you have a gut feeling that there's more nice stuff?
Historically, there is always going to be something with DFU mode and flashing RAM disk to the device, in terms of like getting full file system really good exploits. But I'd say it's also primarily probably worth looking into a lot of the API traffic that's being sent to Apple. Some of the traffic I've looked at, you really just send like your device ID, and it would call back and like say, hey, this is the iCloud email address for this ID, and then from there you could get a lot more.
All right. So people need to find one of these dongles that keeps it online, and a little Faraday cage.
Yeah.
Yeah, like a microwave or something. Awesome. I'm sure there's lots of questions on this.
Yeah, we have a few questions from the audience. And one of them is, okay, you exfiltrate all this, but how much actually usable intelligence do you get out of it? It's like if you try to piece it together.
So I will say, like in actual cases, let's say we're trying to piece together where somebody was at some time. That's a lot of cases. You can usually do that with these logs. It does have a lot of real forensic useful like impact. It's obviously still not as much as a full file system. Lowever, it is a lot better than nothing.
Okay, and the next question, which is relevant for corporate customers, if you have a lockdown MDM mode, is there anything you can do from your like corporate policies to make this harder, or is that's the protection that there is?
I have not yet taken a look into MDM mode. I do know that lockdown mode does not really do all that much in terms of hindering anything that we're looking at.
Okay, because that was the next question. Does the lockdown mode prevent any of this? But apparently no.
Yep.
Okay, that's it.
Wait. But sometimes you got this Safari history. Is that only sometimes?
So for that, it would output the history whenever an error occurred. So let's say you had a few tabs open and you try to open Safari once you are not connected to the internet, it will still attempt to reach out to all of those addresses, and then the phone would say, hey, this is an error, you're not actually connected to the internet, and it would output the URLs and save them in the log.
Okay. Hello? Yep. All right. Then thank you very much.
Thank you.